Hi, this is DressUp, a virtual application that lets you try on clothes virtually without actually you going to the trial room or having the cloth in your hand. So we tried to use edge computing on this because we wanted to save transmission costs for the retailers who are going to use it, and the algorithms which we use are computationally overwhelming, and it's up to 3 GB in size. So running it on a standalone mobile device can be really bad. It takes up a lot of energy and time, and also it does not give a user experience when you run it on a standalone device. So we are using a Gabriel client server architecture, and the PFAF and algorithm does the warping for us. And we are also using MediaPipe, which is an open source platform maintained by Google. It helps us do a lot of customizable ML solutions like face segment detection and segmentation. Yeah. So we're using the pre-processing model to detect if there is a human in the frame, and we segment the background for them, and then we pass it to the PFAFN algorithm to warp the cloth on the given user, and then we give it back to the Android client so the user can see it. Yeah. Yeah. So this is an app, the DressUp application. It helps you choose the clothing of your um, interest, and like when you press the DressUp button, it helps you actually dress up with. This is Shilpa. She's trying the app for us there, and yeah. So this is our concept. Like she's actually not like trying it, and using our application, we are able to show how she would look with the cloth that she selected. Just select. So this is the so this is the client architecture. So when we try to select a cloth, it gets the cloth ID, and when you try to hit the dress up button, it starts the cognitive engine for us, and it does the processing for us. So what you see, the white screen, right? That's the output of the media pipe, which is the pre-processing model which you use. And the cloth warping is actually done with the PFAFN algorithm, which is a combination of two general adversarial networks. The first part is the warp model. It tries to find the correspondence between the given user and the cloth that they have selected, and the generator model tries to pose the input on you, and the output which you see is basically the output of the generative model. Yeah, the Gabriel client server architecture is actually is facilitating the entire communication, and you can see it with almost no latency. The latency is up to 15 milliseconds. That's the maximum overhead which you have. So there are a few points that I would like to highlight. The algorithm works well to a point that, like, let's say, if you wish to, tuck in your shirt, and how would that look? We try to give an output of that, and also this is the significance of our media pipe processing. Without the actual media pipe processing, you could actually see how distorted the result is, and this is with the media pipe processing, and it looks pretty accurate with whatever we see. Also, after checkpoint 2, we also had an opportunity to go through the framework, the Gabriel client server client framework, and the algorithm to know much better. So, which helped us to increase the performance by 20%, and this increase in performance of 20% gave us a leverage of adding this pre-processing module into the framework, and it would still perform much better the way it was working before checkpoint 2. Also, for the 120% goal, we tried to have any apparel working for the given image, and we were able to achieve it. And as part of the demo, we showed the coat shoot and the Indian wear as part of the demo, which worked pretty well. Yeah.